this video, we introduce the contracting map. What is a contracting map? Well, let f be a function from the closed interval ab into itself. We say that f is contracting if we can find some lambda which is greater than or equal to 0 and strictly less than 1, such that for any x and y in the closed interval ab, the absolute value of fx minus fy is less than or equal to lambda times the absolute value of x minus y. We call lambda the contracting factor of this map. Here, we remind the audience that a choice of lambda is once and for all, which means that no matter how the values of x and y are changing, lambda involved in this definition should always be the same. In other words, lambda should be considered as a uniform scaling factor independent of the choices of x and y. Now, to get some intuition, let us try to interpret the geometric meaning of this definition using an example. Here, let us consider the function f from the closed interval 0, 1 into itself, which is given by fx is equal to x squared plus 2 over 3. Now recall that the absolute value of the difference of two numbers actually measures the distance between these two numbers on the real axis. Here, we use a yellow interval to represent the distance between x and y, and the green interval to represent the distance between fx and fy. Moreover, as you can see, we use the dashed line to represent 2/3 of the yellow interval. No matter how we change the values of x and y in the domain, by pulling them away, pushing them together, slide them side by side, or interchanging their positions, the length of the green interval never exceeds 2/3 of the length of the yellow interval, indicating that this is indeed a contracting map where we can take, for example, the contracting factor lambda to be 2/3. It is also very easy to verify this fact by direct computation. No matter what are the values of x and y, fx minus fy, by definition, is equal to x squared plus 2 over 3 minus y squared plus 2 over 3, which is equal to 1/3 times x plus y absolute value times x minus y absolute value. Since x and y are both bounded between 0 and 1, the factor 1/3 times absolute value of x plus y is maximized when x and y are both equal to 1, and that gives us precisely 2 over 3, which agrees with our observation from the animation. As you can see, to verify that a given function is indeed contracting, we might need to perform some algebraic manipulation, which can be messy in some scenarios. However, if the function f is equipped with better regularity, the mission can be much easier. More precisely speaking, let us assume that f is continuous on the closed interval ab, differentiable in the open interval ab. Moreover, there exists some lambda greater than or equal to 0, strictly less than 1, such that for any t in the open interval ab, the absolute value of f prime t, which is a derivative of f evaluated at t, is less than or equal to lambda. If that is the case, we conclude that f is contracting on interval ab. To prove this, simply apply the Lagrange theorem. For any xy in the interval ab, fx minus fy, according to the Lagrange theorem, is equal to f prime c times x minus y, where c is some real number between x and y. Now, upon taking absolute value on both hand side, we see the left-hand side becomes the absolute value of fx minus fy, while the right-hand side becomes the absolute value of f prime c multiplying the absolute value of x minus y. Since we have assumed that the absolute value of the derivative is always less than or equal to lambda, the right-hand side is less than or equal to lambda times the absolute value of x minus y. Now recall that lambda is greater than or equal to 0, strictly less than 1. Thus, the function fulfills the requirement for a contracting map. As an easy application of this proposition, let us go back to the previous example, where f is from 0, 1 to itself, fx is equal to x squared plus 2 over 3. Now, instead of performing algebraic manipulation, let us directly compute the absolute value of the derivative of f evaluated at t, which is given by 2t over 3. Since t is between 0 and 1, this value is less than or equal to 2 over 3. That means we can take 2 over 3 as our contracting factor, and we have thus recovered the consequence achieved previously. Great, now you have seen what is a contracting map. When we study iteration of functions, this is typically the most standard hypothesis we're going to impose on our function. Yet there are some variants of this concept, which we're going to explore in the next section.